Okay, so this to me looks like it's geometric. Let's eliminate the divergence theorem. Essentially, I know that this is not going to go to some non-zero value. I'm just going to, you don't really have to do this, but I'm going to rewrite this as the limit as n goes to infinity of 3 to the n, 4 to the negative 1, 4 to the n, which turns into the limit as n goes to infinity. Since that's a negative 1, it'll be 4, 3 to the n, 4 to the n. This 4 doesn't really have to do anything. As I go to infinity, my numerator is going to grow faster than my denominator. So at some point, this is going to equal 0. So the divergence theorem is not really helpful here. I could have used some other techniques to show that this limit's equal to 0. I just don't really feel like doing it. Bottom line is, its denominator is heavy, so therefore I know it's not going to go to 0. So the divergence theorem is only helpful if your last term is not equal to 0. So this feels geometric. Let's just write out some of the terms. You don't need to do this, but I just want to make sure that we're all on the same page here. If n equals 1, I get 3 over 4 to the 0. If n equals 2, I get 3 squared over 4. If n equals 3, I get 3 cubed over 4 squared. So this is 3, this is 9 4s, this is 27 16s, dot, dot, dot. Clearly, I'm multiplying each term by 3 over 2, right? So my r is 3 over 2. My first term is equal to 1. I find this helpful to write out the first couple terms so it's clear to me what r in A1 is. Notice that n is equal to 1 down here. Sometimes I make that n equals 0 just to be annoying, so make sure you double check that because that's going to affect your first term. So the problem here is that well, my r is not 3 over 2, sorry. My r is 3 over 4. So my common ratio is less than 1. Right, the absolute value of that is less than 1. It's already positive, so I'm not going to absolute value-tize it. If it was negative, I would have just put some absolute value bars on there and said it's less than 1. So my r is less than 1, my a1 is 1, so therefore my sum is going to be 1 over 1 minus 3 quarters, which is 1 over 1 quarter. I'm going to multiply top and bottom by 4, which gives me 4. So you need to write down converges geometric. So what are the things I'm going to be looking for in this problem here? Number 1, I'll be looking for these two things right here. The common ratio is less than 1, and the first term is equal to 1. I'll be looking for the infinite geometric sum. You don't need to write out the formula, but you do. I would ask you to write out this with the numbers plugged in, a1 over 1 minus r. Solve for the value, and then you need to write down converges geometric. Done. Full credit. Okay.